Welcome to the new tutorial where we are going to discuss the two-dimension arrays in C++. So just like the simple array of one dimension in C++, we can also extend that one dimension into two-dimension arrays. Just you can assume that in two dimension we have rows and columns. So in this shape we can actually declare a two-dimension array, and two-dimension array is known as multi-dimension array. So in similar way we can extend this two dimension into the three dimension and then into four dimensions. So it means that C++ supports to declare multi-dimension arrays for different problems. Okay, so in this lecture we are going to discuss the two-dimension arrays. Here you can see. Okay, so in two dimension, let's see an example of this matrix or table. Okay, so in this table or matrix we have two rows and three columns. If you consider this table as a matrix, so like in mathematics, so this can be shown as a matrix. Okay, and this can be a table as well. So make it table. Now we have two rows and three columns. This is column 1, column 2 and column 3. Okay, so this is an exact representation of any table or matrix in any other allied courses, for example the mathematics. Okay, so each element in this matrix or table has its position in the table. Okay, so position can be identified by the row number and column number. Okay, so we have two rows, row number 1 and row number 2. So I have written 0 and 1 because in C++ and majority of the programming languages, arrays have indices started from the 0. So therefore I have written and started it from the 0. So row number 0 and row 1. Okay, in similar way we have three columns in the table, so I have shown three columns here as a position wise: column 0, column 1 and column 2. Okay, so normally we represent the position of the elements in a table or matrix by row number and the column number separated by comma. So this is a mathematical representation of the position of the elements. Okay, so 0, 0 represents the first position in the table or in the matrix. Okay, 0, 1 represents the second position in the matrix or in the table. Similarly 0, 2. So the first 0 represents the row number and the second 0 represents the column number. Similarly in the other position as well. Okay, you can see in the row number 1 that all positions are started from 1. Okay, so 1, 0, it means that we are in row 1 while column 0. We are in row 1 while column 1. We are in row 1 and while column 2. So these are the positions through which we can access the elements inside the table or matrix using any programming, majority of the programming languages, just like in the C++. So this is why I have represented that how can we access the elements through the positions. So these positions are actually be working in the C++ language, and through these positions we will access and render through this table. Okay, this is also the representation of the two-dimension table or maybe matrix. Okay, so because we have row and column, so there are two dimensions in this one. So we will replicate this table through this position, through these positions in two-dimension array in the C++ language. So let's see how can we transform this table and positions into the two-dimension array. Here we have the programming in C++ language where we define actually the integer main function. Okay, so in this function we have declared a two-dimension array. So how can we declare a two dimension? by putting the square brackets. Okay, so first square brackets represent the number of rows, while the second square bracket represent the number of column. In other words, this can also be known as arrays of arrays. So it means that the first declaration represents that there are two arrays. Okay, there are two elements actually, and in each element we have three different elements. Okay, here you can see we have two elements, and in each element we have three different elements. In each element we have three different elements. Therefore, this concept in the C++ is also known as arrays of arrays. So in similar way, we can also introduce the three-dimension arrays of arrays of arrays. Okay. Okay. So we have actually declared a two-dimension array where we have 2 rows and 3 columns. Okay, so how can we identify the number of elements that we can save in the two-dimension array? Just by, the answer to this question is to multiply the number of rows with the number of columns. So 2 multiplied by 3, 2 multiplied by 3 is equal to 6. So it means that we can save 6 elements in this two-dimension array. If there is a three-dimension array, so it means that you need to multiply the size of each index. Okay, size of each element, size of each column, rows and array. Okay. Okay, so we have the syntax. This is a very simple syntax to initialize values in the two-dimension array, where we have put it the assignment operator first and then the square brackets. Okay, terminated by a semicolon terminator, and we have assigned 6 elements into the array. This is a very simple way to initialize two-dimension array. We can also initialize three-dimension array in the similar way. Okay, and you remember that we also in our previous lectures we have discussed that in similar way we can assign the values into a single dimension array as well. Okay, but as from here initialization part we cannot comprehend that whether this array is two-dimension or not. Okay, so the best way to initialize the values is introducing brackets for the rows. Okay, for the rows separated by comma. So this is the best way to initialize the values in the two-dimension array, and this is also a standard way. Okay, so if you use the previous one, so there is no syntactical error or syntax error in the previous initialization, but that is not much more comprehensible and easy to understand for the programmer even. Okay, so therefore we need to introduce the brackets, these curly braces inside the curly braces, and these curly braces should be introduced for the rows. Okay, separated by comma, remember that. So for the first row we have these elements, and for the second row we have these elements. Okay, so in this way we have assigned 2 in the first position, 3 in the second position, 4 in the third position, and 6 in the fourth position, and similarly in the fifth and in the sixth position we have assigned 5, value 5. Okay, so this is the declaration initialization part of two-dimension array. So how now can we render through this array? As we have initialized this and all the spaces are being reserved in the memory. So remember that when we talk about the memory, so memory reserves spaces for each data type. So here we have introduced integer data type. So it means that for each element of integer data type, the memory will reserve 4 bytes in the memory, in the RAM. Okay, 4 bytes. So how many elements we are introducing here? We are introducing 6 elements in the array. So therefore 6 multiplied by 4 bytes. So it means that we are actually reserving 24 bytes in the RAM for this two-dimension array. Okay. So let's talk about the accessing the elements of the two-dimension array. We can say the table or maybe the matrix. So we have introduced the outer loop. This is the outer loop. For integer, r is equal to 0, r is less than 2, and r plus plus. We have initialized r with 0 just because we are introducing this outer loop for the rows, okay? For the rows. So we have two rows now. And for the first row, we have index number 0, while for the second row, we have index number 1. And there is no third row, okay? So therefore, we have no index number 2 in our two-dimension array. So here you can see that we have index number 0 for row, first row, and for the second row, we have index number 1. So therefore, we have started r with 0, initialized with 0. So this loop will be starting from the 0. Okay, and r is less than 2. So what does it mean? That we are not approaching to the 2. Our loop, our first loop should be iterate through row 0 and row 1 only. And then when r actually updates to the 2, then the condition must be false because we have no row number 3 in our table or matrix, okay? So this is the outer loop introduced for the rows, and this is the inner loop introduced for the columns. So we can also say that we have introduced the nested loops concept here in this programming, okay? And remember that we have a body for the outer loop, okay? We have introduced a body for the outer loop, and in this body we have an inner loop with the single line statement terminated by a terminator semicolon, okay? And then there is another statement which is not intact with the inner loop, okay? This statement doesn't come under the body of the inner loop. This statement comes in the body of the outer loop. So it means that in outer loop we have two statements. One is the for loop, this one, okay? And second is this in the cout statement, which has end else operator here with a terminator. So these are the two different statements enclosed in the body of the outer loop. Okay, so we were talking about the inner loop. So inner loop is being introduced for the number of columns, okay? So first we have to approach to the 0 row, and then in each row we have to approach a number of columns. So we will start from the 0 column, 1 column, and then 2 column. Then we will update the outer loop and will access to column 1, column 2, and column 3. So in this way we will iterate and render through all the elements of the two-dimension array. Okay, so remember that columns are also, start from the index number 0. So column 0, column 1, and column 2, and there is no column number 3. There is no column with index number 3, okay? We have 3 columns, but there is no index number 3 column. Okay, so starting from 0, then update to 1, and then update to 2. When we update column to 3, index number 3, so our loop shall be terminated. So this is the inner loop, part of inner loop. This is the part of the outer loop. Okay, so here you can see in the inner loop we have started c is equal to 0. This is the control variable of the inner loop, starting with 0, and c is less than 3 because we have no 3 in the columns. Okay, so therefore iteration 0, iteration 1, and iteration 2 are acceptable, which are less than 3. But when it becomes 3, that is not acceptable because we don't have any column and with index number 3. So less than 3, and then we are incrementing c with 1 using the increment operator. Okay, so this is the update statement, this is the conditional statement, and this is the initial declaration and initialization statement. Okay, inside the inner loop we have a single line statement. Okay, so in this statement we are going to access each element of the array. And this is the visual representation, okay? How can we access? We are going to print the a and square bracket as it is. Then we are going to print the value of r in the first iteration, of the outer loop. Then we are printing square brackets on the screen. Then we are printing c for the inner loop, and then we are printing as it is square bracket and equal sign, and then we are using the name of array with indices number. So in the first iteration of the outer loop, and this body will be executed. So in the first iteration, r will be equal to 0, okay, and then this body will be executed, so c will also be equal to 0. So it means that in the first iteration we are going to access a of 0 and 0. So this is the syntax. How can we access an element in the two-dimension array using the indices numbers, okay, using the indices. So I have already mentioned here that how can we use indices of the array to access each position of the array, okay. So write the name of the array just in the prefix of the square brackets. We have written here, you can see a is the name of the array, and then you shall write the position numbers to which you want to access, okay. So in the first iteration we are going to access 0 and 0. So 0 0 is the position of element, first element. So we will see 2 on the screen. 2 on the screen. How can we see it? The printing will look like a of this statement, then value of r. So in the first iteration value of r will be equal to 0. Then we are printing the square brackets, the closing and the opening. Then we are printing the value of c. So in the first iteration the value of c is 0. Then we are printing the closing square bracket and the assignment operator inside the double quotes. So as it is, it will be printed as it is. And then we are printing the value inside the two-dimension array, which is, you know, on the index 0 and 0. So index 0 and 0 representing the first position, and at the first position we have value 2. So we will see here value 2 on the screen, and then we are printing a space. Here we will see a space on the screen, okay. So in the second iteration of the inner loop, when execution will come to the C++, so C will become 1, okay. C will become 1, and 1 is less than 3, yes. So in similar way we will see the output on the screen for position. So as C has been updated to 1 and R is still 0, so therefore we are accessing to the position, second position in the matrix, okay. So on second position we have the value 3. So in a very similar way, separated by space, we will see the output of this statement. So let me introduce second iteration of the inner loop will look like, separated by space, a of 0 and a of 1 is equal to 3. This will be the output of the second iteration, okay. In the third iteration, C will be updated to 2. It was 1, so now it will become 2, and R is still 0, okay, because we are in the body of the outer loop. So C is 2, so 2 is less than 3, yes. Now this statement will be executed for R is equal to 0 and C is equal to 2. So this statement will print the output separated by space just in front of the, you know, these second position, and we will see 0 is equal to 4. So exactly this will be the output of the statement in the third iteration. And in the fourth iteration, C will be updated to 3. So 3 is less than 3? No. So the inner loop will become false and the execution will be terminated for the inner loop. So therefore, execution will come to the C out statement, this statement, okay? The execution will jump out of the body of the inner loop and will come to the C out statement of the end L, okay? So this end L will direct the console screen, the cursor, to jump on the next line, this line, okay, here. So this is the simple output of the, of the end L on the screen. Now the execution, because the body has iterated for once only, so therefore execution will come to the R++. And R is actually now 0, so after execution of R++, R will become 1 for the outer loop, okay? So as in the outer loop, we are going to see the number of rows, so therefore R is now equal to 1. So now we will iterate through this row, okay, which has index is equal to 1. So now R is equal to 1. 1 is less than 2? Yes, 1 is less than 2. Therefore, this body, the body of outer loop, will again iterate in a very similar way, just was in the first iteration of the outer loop, okay? So it means that this body will be executed now, and in this body the inner loop will execute for 3 times, okay, for 3 times. So just like in the first row, we in the second row we have also 3 columns, okay? Initializing C with 0, so 0 is less than 3, yes. So in very similar way, R is equal to 1 while C is equal to 0, yes. So 1 and 0, okay. So in very similar way on the screen, we will see A as it is with square bracket, and we will see the value of R has been updated to 1 and value of C is equal to 0, because this is in the first iteration and 1 is in the second iteration of the outer loop. 0 is in the first iteration of the inner loop, okay. And then we will see that A of now R is equal to 1 and C is equal to 0, okay. So 1 and 0 represent the fourth position in the 2-dimension or array or the matrix or the table. So this is 1, 0, which represents the value 6, okay. So therefore we will see we will see 6 on the screen. And then execution will come to update C++. So C was 0, now C will become 1, and a very similar way we are approaching to print the value of 1 and 1. So the value of 1 and 1, value of 1 and 1, which is 1, okay. A of 1, we are in row 1 and now we are in column 1. So the value of 1, 1 is 1, separated by space. So we will see a space here on the console screen. Then the execution will come again to the C++, and C is 1. After execution of plus the increment operator, the value of C will become 2. So 2 is less than 3, yes. This statement will be again executed, okay, for value 2. So A of 1 and 2 is the position, you can see 1 and 2, the last position in the table or matrix or the 2-dimension array. So the last position has value 5, and you will see the output on the screen is like this. 1 and column 2, and the value of last position is 5. And then the execution will come to C++. So C will become 3, and 3 is less than 3. No, 3 is not less than 3. So therefore the inner loop will terminate, and the execution will come and jump out of the inner loop to the cout statement. Okay, and cout statement will direct the cursor to jump on the new line here. And then the execution will come to the update statement of the R++. Okay, so R will become, R was 1. Okay, here you can see. So R will become 2. Now 2 is less than 2? No, 2 is not less than 2. And as we have no row here that has index number 2, so therefore we have put this condition as keeping in the mind that we have no row has index number 2. Okay, so this condition will become false, and the execution will straight away come and jump out of the body of the outer for loop. So as there is no statement, or you may write a return statement here, so that statement will be executed and your program will be halted here. Okay, so this is how we can access actually the elements inside the array. How can we initialize the elements of array? Okay, and how can we represent a table or matrix having some positions and then convert those positions into array representation using index numbers. Okay, so remember that whenever you want to introduce a two-dimension array, you need to introduce the two square brackets. Okay, the first one for the rows and the second one is for the columns. Now let's discuss how can we initialize these values, these hard-coded values, by taking input from the user. So you just need to change the statement here. Okay, so in this way we can initialize the values on each position sequentially. Okay, starting from the first position and then ending on the last position of the array. Okay, and you are also recommended to please give a message just before the for loop, the outer for loop here, the cout statement to the user that please enter how many elements? 2 cross 3, 6 elements in the two-dimension array. Okay, so in that way the outer loop will be executed, and then the inner loop will be executed, and then this statement will be executed for the 6 times. Okay, 3 times for one row, 3 times from another row. So in this way the user will be able to input the values inside the two-dimension array, and then we don't need to initialize the array in the startup program. Okay, so this is a very simple way how can a user actually initialize the values inside the two-dimension array. Okay, so this is a very simple concept of how to introduce the two-dimension array in the C++. Similarly, we can introduce the 3-dimension arrays, even 4-dimension arrays, even you can increase it to the multi-dimension. So it actually depends on the program or the problem that you are going to solve using the C++ program. So for example, if you want to introduce 3-dimension array, so for that you need to introduce the square brackets with for example, this is an array, 3-dimension array with name A having 2 arrays. Okay, and then each array we have 3 rows, and in each row we have 5 columns. Okay, so in this way we can introduce 3-dimension array, and we can access and then we can use the 3 nested loop to access the elements or to initialize the elements inside the 3-dimension array. Okay, so thank you so much for watching this this lecture of two-dimension array or multi-dimension array in the C++. If you have any questions, so please ask me in the comments below, and inshallah I will try my best to answer all those questions. Thank you so much once again.